Hello friends, now we will start the new chapter, Understanding Quadrilaterals. It's very simple and important chapter. Now first introduction. You know that the paper is a model for a plane surface. Paper is nothing but the plane surface. When you join a number of points without lifting a pencil from the paper, you get a plane curve. Okay. Suppose that these are the points, and if we join it, then this is the plane curve. Okay, without lifting the pen. Now the next, see this some figures and their types. Okay, if you observe this figure and the type, see this here types. Is a simple closed. A closed curve is not a simple. Simple curve is not a closed and not a simple. We see this the first one. This is the simple curve, but it is not the. I think it is. This is the not closed curve. Okay. What about the second? Second, this someone is a closed, but I think that it is not the closed, but it is not the simple. And what about this circle? Circle is a simple closed curve. Okay. And next is a, again for this, again this is the closed curve, but again it is not the simple. Okay, in this way you can distinguish. Now the next, what do you mean by the polygon? A simple closed curve made up of only 9 segments. Only, this is important, line segment is called the polygon. These are the line segment and it is a closed. Therefore, this is the polygon. All are the line segment. It is a closed. These are the line segments and therefore it is called the polygon. Polygon has a sides 3 and more than 3. Okay. All these curves are the polygon. Now these are not the polygon. It is not the closed. This is again the points are overlapping. This is not the curve. These curves are not the polygon. Okay. Now the next, number of sides or the vertices. Classification, simple figure. If there are the 3 vertices, then it is a triangle and this is the figure. 4 vertices, then it is a quadrilateral and this is the figure. 5 vertices, then it is a pentagon and this is the figure of the pentagon. 6 vertices, then it is a hexagon and this is the figure. It has 6 sides, 6 angles. 7 sides, then it is a heptagon and this is the figure. It has 7 sides, 7 angles. Octagon, okay, 8 sides, 8 angles. Next is a nonagon, okay, and this is the figure. 10 sides, it is a decagon and this is the figure. And if it has a n sides, then it is a n-gon, but the figure we cannot draw it. Okay, and in this way, very simple, the number of the sides or the vertices, then the classification, and these are the figures. Okay, now what we mean by the diagonals? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. For example, see this here, PQRS, this is the quadrilateral, and suppose that I want to draw the diagonal, then I will not take the point Q I will not take the point S because P and Q and S are the consecutive points for the point P. Therefore, I will join the point R with R. Therefore, PR is the diagonal. Next, S. I will not join with this R and the P. I will join with the Q. And therefore, this quadrilateral has the two diagonal. See this next figure. Here, these are the vertices and we can join the first EA is not the diagonal. Okay. ED is not the diagonal. Then which are the diagonals? EB is the diagonal because B is a non-consecutive vertex. C is a non-consecutive vertex and in this way we can join the diagonals. What about the triangle LNK and it has no diagonals. Okay. If I want to if I join this LN, it is a consecutive. If I consider LK, again it is a consecutive. If I consider the triangle LNK, it has the no diagonals. Okay. Now the next, can you name the diagonals in each of the above figure? We can name the PR and the SQ. These are the diagonals. What are the remaining diagonals? EB, next is a BC and AD and DB. Okay, AC. These are the diagonals. Again, you say that PQ is a diagonal. PQ is not the diagonal because the point Q is a consecutive point. LN is a diagonal. LN is also not the diagonal. Okay. Next, see this figure. It's a closed figure. This part is in the interior. See this is the boundary. All the points inside this figure is the interior part of this figure. And what about the exterior? This is the exterior part of the figure. Okay. Now the interior has a boundary. Does the exterior have a boundary? Yes. I will say that there are here the two boundaries we will consider. Exterior part, outer part does not have any boundary. It extends infinitely. But the inner part, this is the boundary. Okay. Now the next is see this polygon. All these polygons are convex polygon. We will call this convex polygon. If we join any diagonal of this figure, all the points of that diagonal lies within the figure and therefore it is a convex polygon. You can join again. Or if you take any 2 points inside this figure and join it and the points between this P and Q, all the points lies between P and Q and therefore it is a convex polygon. You can take any 2 points, join it, all the points between this A and B are in between A and B and therefore it is called all these polygons are the convex polygon. What about these? These are not the convex polygon. Why? If I take the 1 point here and this is here. Okay, this is a P and Q. And I join these points, then all the points between P and Q does not lie in the interior of this figure and therefore this is not the convex. Okay. Same thing is also here. If you take any 2 points and join that 2 points, all the points between that 2 points lies inside that figure. Again, here if we join this part lies in the exterior of this figure. Therefore, this is also not the convex. Okay, it is a concave. All these figures are the concave. Okay, these are the concave figures. Okay, now the next is a can you find how these types of polygons differ from one another? Polygons that are convex have no portion of their diagonals in their exteriors or any line segment joining any two different points in the interior of the polygon. Okay, if we take any 2 points polygon and lies wholly in the interior of it. Okay, the diagonal lies in the interior. If we take any 2 points and all the points between that 2 points lies in the interior, and therefore these are called the convex polygon. Is this true with the concave polygon? No. In our work in this class, we will discuss here only the convex polygon. We will discuss here only the convex polygon. Okay. Now the next definition is a regular and irregular polygon. Then what is meant by a regular polygon is both equiangular, okay, and equilateral. Means what? A polygon in which all angles are equal and all line segments, all sides are equal, then it is called the regular polygon. Okay, we'll say that the equilateral triangles, squares, these are the regular polygon. Equilateral triangle, it means that all the sides here, all the sides are equal and each angle is a 60-60. Also we draw this square. Suppose that it is a square and this lines denotes the all these sides are equal. Each angle is a 90 and therefore these figures are called the regular polygon in which all angles are equal and all sides are equal. Okay. For example, a square has a sides of equal lengths and angles of equal measure, and hence it is a regular polygon. Rectangle, what about the rectangle? If we take the figure here, the rectangle, here the all angles are equal. All angles are equal. But what about the sides? These two opposite sides are equal. These two are equal. All the sides are not equilateral. Therefore, it is not the regular polygon. Okay. Now, therefore, the rectangle is not a regular polygon. No, even right here. Is an yes, here the equilateral triangle. This is the regular polygon. Okay. This square is a regular polygon. But what about here? This triangle is not the regular polygon. Rectangle, though all the angles are equal, but the sides are not equal. Therefore, this is not the regular polygon. Now, some figures again. These are the regular polygon. See this. This indicates that all the sides are equal, and also this same notation denotes that the all angles are equal. This is the regular pentagon. This is the regular hexagon. Okay. And what about here? Only these for this figure. These two sides are equal and all angles are also not equal. Therefore, this is not the regular polygon. In this figure also, the opposite sides are these are equal and these are the different one. Therefore, this is also not the regular polygon. Okay. In previous classes, have you come across any quadrilateral that is equilateral but not equiangular? Yes. The rhombus was the figure in which we have all the sides are equal, but it was not the equiangular. Okay. And what about recall the quadrilateral shape you saw in the earlier classes. You can see this, the rectangle. It is not the regular polygon, but the square is a regular polygon. Rhombus is a equilateral, but it is not the equiangular. Okay. Now, next. Angle sum property. Do you remember the angle sum property of a triangle? Yes. The sum of measures of the three angles of a triangle is 180. This is the. Now we'll start the exercise 3.1. Exercise 3.1. Given here some figures. See this here. Total 8 figures are there. Now the first question. Classify each of them on the basis of the following simple curve. Now see this here. The 1, 2, 5, 6, 7. These are the simple curve. 1, 2, 5, 6, 7. These are the simple curve. And 3, 4, 8. These are not the simple curve. Okay. Now see this the simple curve. Next, simple closed curve. Simple closed curve. Again, 1, 2, 5, 6, 7. These are the simple closed curve. Okay, 1, 2, okay, 5, 6, 7. These are the simple closed curve. Now the next type of figures, polygon. Now again I will repeat here the definition of the polygon. A simple closed curve made up of only line segment is called the polygon. Only the made up of the only line segment. And what should be it must be the closed. Therefore the 1, 2, 4. These are the polygon. They are made up of the line segment. Okay. This is made up of the line segment closed, made up of the line segment closed, made up of the line segment closed. These are the polygon. This is not the made of the line segment. This is also curve, this is also curve, curve and curve. Okay. Then which are the polygon? 1, 2, 4. These are the polygons. Okay. Now the next is convex polygon. Again we have seen that if you take any 2 points in this interior of this polygon and join it, if all the points between them and that 2 points lies inside this polygon, then inside this curve, then it is called the convex polygon. Okay. And also all the diagonals lies inside this polygon. Therefore it is called the convex polygon. Here, if we take the polygons only, and this is only the convex polygon. What about here? This is the polygon. If we join this and all the points inside this segment does not lie, therefore it is not the convex. This is also, if we take any 2 points and join it, all the points does not lie. Okay, this some part lies in the exterior, therefore it is not the convex polygon. Only figure 2 is a convex polygon. Next, concave polygon. Okay, these are the concave polygon. If we take any 2 points and join it, and this part lies in the exterior, then here it lies in the exterior part. The points lies in the exterior of the figure with polygon, and therefore it is not the convex, it is a concave polygon. This is the concave. And what about this? This is the convex. Okay. Now next question. Question number 2. How many diagonals does each of the following have? First is a convex quadrilateral. This is the convex quadrilateral. AC and BD, these are the two diagonal. It has a two diagonal. Again, there is one more formula, that is a D is equals to N into, in bracket, N minus 3 upon 2. If we substitute N is equals to 4, then it is a 4 minus 3 upon 2. Then what you will get? 4 into 1 upon 2, that is equals to 2 by using this formula. That is D is equals to N into N minus 3 upon 2. You can find out the number of the diagonal. Okay. For this figure, okay, it is a regular hexagon, and total, if we count this is a 1, 2, okay, 3, 4, 5, 6, 7, 8 and 9. It has the 9 diagonals. Again, you can find out by using that formula. D is equals to N, in bracket, N minus 3 upon 2. Okay. Substitute N is equals to 6, in bracket, 6 minus 3 upon 2. Okay. And after simplification, you will get 6 into 3 upon 2, 18 upon 2, and here it is a 9. Therefore, the number of diagonals are 9. And what about the triangle? It has no diagonal. And using this formula, you can also calculate. That is a D is equals to, how many sides are here? 3 sides. 3 in bracket, 3 minus 3 upon 2, and that is 3 minus 3, that is 3 into 0 upon 2, and overall that is a D is equals to 0 diagonals. Also here we cannot join the vertices, non-consecutive vertices. Okay. Now the next question. What is the sum of the measures of angles of a convex quadrilateral? Will this property hold if quadrilateral is not convex? Okay. Yes, we can find out the sum of measures of angles of convex quadrilateral. See this figure. In this figure, A, B, C, D, this is the convex quadrilateral, and if we join this diagonal AC, the angles are 1, 2, 3, and another angles for the triangle ABC, they are 4, 5, 6. Okay. Can find out the sum of measures of angles of the triangle. And in first triangle, the measure of angle, measure of in triangle first. In triangle A, B, C. What's happening in triangle ABC? The measure of angle 4 plus 6 plus 5, that's equals to 180. That is angle 4 plus angle 5 plus angle 6, and that's equals to 180. This is the first part. Again, in triangle A, C, D. What's happening? That is a angle 1 plus angle 2 plus angle 3, and that is also equals to 180. Okay, this is the second one. If we add these, then you will get here, that is a angle 4 plus angle 5 plus angle 6. And what about here? Angle 1 plus angle 2 plus angle 3 angle, there is a 3, that is equals to here the right hand side is a 180 degree plus 180, and that's equals to 360. Now we'll take the first of all angle A means what? Sum of the 1 and 4. 1 and 4. Therefore, I will write here in bracket angle 4 plus angle 1. What about the angle B? It is angle 6 only. Angle 6. And next, what about the angle C? 2 and 5. Therefore, here angle 2 plus angle 5. Okay. Now, what is remaining? Angle 3 plus angle 3, and that's equals to 360 degree. What about the angle 1 plus 4? It's angle A. Next, angle 6 means what? Plus angle B. Angle 2 plus 5 means what? Angle C. And angle 3 means what? Angle D. Okay. And that's equals to 360. Hence, answer, that is the sum of measures of angles of convex quadrilateral is 360. You can see this. Okay. Now the next, what is that? Will this property hold if quadrilateral is not convex? Now see this here, the convex figure. Okay. We can join this diagonal BD. Okay. Then here we will get the two triangles. Here's the angle 1. This is the angle 2 and angle 3. This is the angle 4. Okay. Angle 5, and this is the angle 6. Now here we consider the two triangles. Therefore, I will write here in triangle A, B, considering this triangle A, B, D. Okay. What about their measures? Angle 1 plus angle 2 plus angle 3, and that's equals to 180. That is the sum of measures of angles of the triangles. This is the first one. What about in another triangle? In triangle BCD, this is the BCD. Okay. The angle 4 plus angle 5 plus angle C, and that's equals to 180. Okay. This is the 2. And therefore, we can write here from 1 and 2. From 1 and 2. We will add their left hand side simultaneously right hand side. Okay. 1 and 2. That is angle 1 plus angle 2 plus angle 3. And here also plus angle 4. This is the 6. Plus angle 4 plus angle 5 plus angle 6, and that's equals to 180 degree plus 180. Okay. Now first of all, angle, this is the 1. Next is a angle 2 plus 4. It makes the angle B. Therefore, I will write here angle 2 plus angle 4 in a bracket. What about the next? Angle 2. Next, I will write here only the angle 6 because it is treated as angle C. And next is a angle 3 plus angle 5. This is the sum. Okay. And this equals to 360. Okay. Now see this, that is the angle A plus angle B plus angle C plus angle D, and that's equals to 80. This next example. Okay. Examine the table. Each figure is divided into triangles and the sum of angles reduced from that. Now see this figure. This is a triangle. 3 sides are there. Okay. And therefore, here we can write here 3 minus 2 into 180. What about the next? 4 sides are there, minus 2. That is a 4 minus 2 is a 2. 2 into 180. That is a 360. What about the 5? 5 sides are there. 5 minus 2 into again 180. That is a 3 into 180. We get the 540. Next, 6 minus 2. 6 sides are there into 180 and again 4 into 180. Then what will the formula will be there? If there are the n sides, n minus 2 into 180. This will be the formula to find out the sum of measures of any polygon. Okay, where the n sides are there. Now we'll find out the sum of measures of angles of the convex polygon having the number of the sides first 7. Now the solution. Here n is equals to 7. Now the angle sum of polygon is equals to in bracket n minus 2 into 180, and that's equals to 7 minus 2 into 180, and this is the 5 into 180, and that's equals to 900. Therefore, angle sum of polygon is equals to 900. Okay. Now the next problem. Here's the solution. Here n is equals to 8. Again, angle sum of polygon is equals to n minus 2 into 180. Okay, n minus 2 into 180. Substitute the value 8 minus 2 into 180, and here we get 6 into 180, and therefore you will get here 1080, and therefore I will write here angle sum of polygon is equals to 1080. You can see this. Okay, now the next problem solution. Okay, here n is equals to 10. Therefore, angle sum of polygon is equals to n minus 2 into 180. Okay, and that's equals to 10 minus 2 into here 180. Okay, and that's here 10 minus 2 means what? 8. 8 into 180. Okay, and therefore their multiplication is 18 into 8, that is a 144, and here one more 0 is. Okay, and therefore angle sum of polygon is equals to 1440. Okay, yeah. Now when the sides are n, therefore the solution here n are the number of sides. Therefore, angle sum of polygon having n sides, that's equals to n minus 2 into 180. Okay, this is the formula, generalized formula. Now the next question is, what is a regular polygon? State the name of a regular polygon having 3 sides, 4 sides and 6 sides. Now answer. Yeah. Regular polygon means what? A polygon with equal sides and equal angles is called the regular polygon. Now first, name of the regular polygon having 3 sides. If the polygon having 3 sides is called equilateral triangle. This is the first one. Next, 4 sides. Polygon having 4 sides is called a square. 6 sides. Polygon having 6 sides is called hexagon. Okay. This question is very easy. It's a question answer type question. There is no calculation. You can see this here. Now the next question, question number 6. Question number 6. Find the angle measure x in the following figure. The solution. Using angle sum property of a quadrilateral okay. Sum of the images of angles of this quadrilateral is 360. Therefore, we first write here 50 degree plus 130 plus 120 degree plus x, and that's equals to 360. Okay. Now here 50 degree plus 130, that is a 180. 180 plus 120, and that's makes 300 plus x is equals to 360, and therefore x is equals to 360 degree minus 300, and that is equals to 60 degree, and hence here x is equals to 60 degree. Okay, answer the value of x. Next problem. See this figure. Here the measure of angle is 90. Therefore, these are the linear pair angle. Measure of this angle, which is the 90. And again, by the angle sum property, of a quadrilateral okay, quadrilateral, that's equals to, first is x here, x plus 70 degree plus 60 degree plus 90 degree, and this equals to 360, and therefore here x plus 70 plus 60, you will get here 130, 130 plus 90, you will get 220, yeah, total is a 220, and this equals to 360, and therefore x is equals to 360 minus 220, and that's equals to 140, and hence here x is equals to 140. This is the answer. So, answer here. Now the next problem. Again here the solution. We want to find out the value of x. Now see this, the number of sides are 1, 2, 3, 4, 5. 5 sides are here, the pentagon. But first of all, we will find out this interior angle and these two angles. The measure of these angles, suppose that it is a y and this is the z. These two angles are the linear pair. Therefore, I will write here 70 degree plus y, 70 degree plus y is equals to 180. What is here? Linear pair. Okay. And therefore, measure of this angle y, 180 minus 70, and that is equals to 110. Therefore, measure of angle y is equals to 110. Again, measure of angle z plus 60, that is equals to 180. Z plus 60 degree, so 180 degree. This is also linear pair. Okay. Therefore, measure of angle z is equals to 180 minus 60 degree, and that's equals to 120 degree. Okay. Therefore, here z is equals to 120 degree. Now, this is not the quadrilateral, it is a pentagon. Therefore, we will find out the angle sum of a polygon having the n sides. Okay. Here, angle sum of polygon, where here n is equals to 5, that is equals to, in bracket, what is that formula? N minus 2 into 180. Okay. And this equals to n is 5 minus 2 into 180, and here that is equals to 3 into 180 degree, which is equals to 540. Okay. Therefore, sum of angles of polygon is equals to 540. Now, from this figure, we'll write here x is 2 times x plus x, y plus z, and the last is a plus 30 degree, and that is equals to 540. Okay, it is here x plus x plus y plus z plus 30 is equals to 540. We want to find out the value of x. Therefore, x plus x is equals to 2x. I have calculated the value of y. What is the y? Y is 110 and z is 120. 110 plus 120 degree plus 30 degree, and that is equals to 540. Okay, and therefore here 2x plus 110 plus 120, that is a 230, 230 plus 30, 260 is equals to 540, and therefore here 2x is equals to 540 minus 260. Now the subtraction, 540 minus 260, that is equals to 280. This equals to 2x, and therefore x is equals to 280 upon 2, that is equals to 140, and hence the x is equals to 140. See this? This is the answer. Now the next problem. Find out the value of x. Again the solution. This is a pentagon, and again from this above example, what was the angle sum when n is equals to 5? It was the 540, and using this I will write here answer. Therefore the angle sum of polygon n is equals to 5, and that's equals to, we have just calculated, it is a 540, and this equals to x plus x, 5 times x, I will write here x plus x plus x plus x plus x, and that's equals to 540, and therefore here 5x is equals to 540. Now their division. Okay, therefore x is equals to 540 upon 5. Division is 5 ones are 5 1. Next the division of the 0, and 5 8s are 40. Therefore the value of x is equals to 108 degree. This is the answer. Angle sum property when n is equals to 5, just we have calculated, it is a 540. Therefore sum of the all angles is equals to 540, 5x is equals to 540, and you will get the value of x. Now we take the next problem. Now the question number 7, find the value of x plus y plus z. Okay, now here the solution. See this here, these triangles are linear pair. Therefore from figure here, x plus 90 degree, and that's equals to 180 degree. Right here, number 1. What is here? Linear pair. Okay, this is the first one. What about the second? Again here we calculate the first value of x. X is equals to 180 degree minus 90 degree, and that's equals to 90, and therefore here x is equals to 90 degree. This is the first one. Now see this here, the measure of angle y is equals to, what is the measure of angle? This, consider this triangle. In this triangle, this angle y is a extra angle, and the measure of this extra angle is equals to sum of its remote interior. Therefore, angle y, that's equals to sum of its remote interior, means what? 90 degree plus 30 degree, right here 90 degree plus 30 degree. Okay, now what is the here reason? Exterior angle property. Exterior angle property. What is that property? The measure of exterior angle of a triangle is equals to sum of its remote interior, which are the 90 and the 30 degree. Therefore, angle y is equals to 90 plus 30, and that's equals to 120 degree. And this is the second one. Okay. Now, lastly, we find out the value of z. Again, angle z plus this 30 degree, that is equals to 180. These are the linear pair. Therefore, angle z is equals to 180 degree minus 30 degree, and this equals to 150. Therefore, angle z is equals to 150 degree, and this is the third one. Okay. Now here we want to calculate the value of x plus y plus z. Therefore, here angle x, measure of angle x plus measure of angle y plus measure of angle z. What's the measure of angle x? Here, here angle sign. Okay. Measure of angle x is 90 degree. Measure of angle y is 120 degree. Measure of angle z is equals to 150. 90 plus 120, that is a 210 plus 150, and that's equals to 360. Hence, angle x plus angle y, or the angle z, that's equals to 360, or the x plus y plus z, that is equals to 360. Okay. First, we find out the value of x. Then, by using the extra angle property, we find the value of y, 30 plus 90. Again, the linear pair, we find the value of z. And then we take the x plus y plus z, that is a 360. Now, the next problem. Now, from this figure, we want to calculate x plus y plus z plus w. Okay. Now, here, the measure of this angle, suppose that it is a A. Solution. Here, using It's a quadrilateral angle sum property of quadrilateral okay. Then what is the sum of the angles? That is here 60 degree plus 80 degree plus 120 degree and plus A, and this equals to, it is a quadrilateral, sum is equals to 360. Okay. If you add it, what is here 120 plus 80, the 200 plus 60, here you will get 260. 260 plus A, you will get here 360. Okay. And therefore the measure of angle A is equals to 360 minus 260, and that is equals to 100. Okay. Therefore here A is equals to 100 degree. Now here we calculate the independent values. Now here the first 120 plus x, that is equals to 180, 120 degree plus x is equals to 180, the linear pair angle, therefore x is equals to 180 minus 120, and that's equals to 60. Therefore here x is equals to 60 degree. This is the first one. In this way we will calculate the y. Again angle y plus, or you can write only the y plus 80, y plus 80 degree, that is equals to also 180. The same reason, linear pair angles, and here therefore y is equals to 180 degree minus 80 degree, that is equals to 100. Therefore y is equals to 100 degree. This is the second one, y. Next z plus 60 degree. Again z plus 60 degree, that is equals to 180, and here linear pair angles, therefore z is equals to 180 minus 60 equals to 120. Therefore z is equals to 120, and this is the third one. Okay, and the last is here 100 plus w, that is equals to also 180. 100 degree plus W. This is also 180. Again, there is a linear pair angles. Okay. And therefore, here you will get W is equals to 180 degree minus 100 degree, and that's equals to 80 degree. Therefore, W is equals to 80. And this is the fourth one. Now we will add all these. Okay. Therefore, here x plus y is the question. X plus y plus z plus w. Therefore, x plus y plus z plus w, and that's equals to x is 60, y is 100, y is 100, z is 120, and w is 80 degree. Okay. Now there is a 160, 280, 280 plus 80, and again that is equals to 360. Okay. And therefore here x plus y plus z plus w, and this equals to 360. Okay. Its total is a 360. You can see this. And in this way, we have completed this exercise. We'll see in the next video. Till then, goodbye.